of Design and Architecture Swarnabhumi takes a great privilege to welcome you all to the MIDAS Webinar Series 32, a demo session on parametric design by architect Prabhat Arora, principal at Arora Architects and also a founder of Architectural Intelligence. Now I request our beloved principal of MIDAS, Professor Parisuddha Rajan, to deliver the welcome address. Over to you, sir.
Thank you, Hema. Very good afternoon to one and all. A warm welcome to our today's webinar speaker, Architect Prabhat Arora. Welcome. Nice to meet you. Nice to meet you virtually. And also, we are so eager to understand the architectural intelligence that they're going to talk about through parametrics. So today, we all know we are in the digital era, and we have to embrace technology to its fullest possible way to leverage our design skills to upscale ourselves to the next level of creating the spaces what we intend to or what we dream to as an architect. So how this subject or this specialization on parametric design is going to help us in doing that scaling up is going to be today's talk, and definitely we'll be happy to listen to you, and also we are very eager to listen to you as I told you earlier, and also we further would like to extend this towards a workshop, towards a learning which will be hands-on for all our students of architecture at bachelor's as well as a master's level here at MIDAS. With this few words, once again I welcome you for this wonderful webinar on this trendy topic, and also now it's over to you to take out the stage and please proceed.
Thank you, sir. Now I request Professor Narayanan for a guest introduction.
Good afternoon to all. A very warm welcome to every participant who is present here. I feel very happy to introduce our today's guest, Architect Prabhat Arora. Prabhat Arora holds a master's degree in Master of Architecture from Architectural Association Design Research Laboratory. He is the principal architect at Arora Architects. He is the founder of Artificial Intelligence. He has designed and built his first project at the age of 22 at IIT Madras and continues to design to all scales from product to city scale. His interests lie in complex geometry, bio-inspired design, parametricism, and robotics. He is currently teaching at multiple universities and is relocating to London to work on higher-end projects with an international office. So with these few words, now I invite Architect Prabhat Arora for the webinar. Over to you, sir.
Thank you so much. So I'm just going to share my screen and then I'll get started. I just want to sort of explain to you where I come from and how I got interested in digital design. And then I will also move on to explaining what parametric design really is and how it was established and the multiple facets of parametric design and the digital and architecture. I'm just about going to share my screen. Give me 1 second. I hope you all can see my screen.
Yes, perfect.
All right, great. So, like Professor Narayan said, I'm Prabhat Arora. I'm a graduate of the Architectural Association Design Research Lab in London. I was part of Patrick Schumacher's studio, and I've designed and built at multiple scales from a very early age, whilst I was still a student of architecture at the age of 22. I've recently, in the past year and a half, I've been teaching at multiple universities, imparting knowledge on parametricism and digital tools and artificial intelligence within the realm of architecture. And that being said, I will also be relocating to London in the coming month to work on high-end projects in conjunction with Zahadid Architects. Give me 1 second. So that being said, let's just get started. The digital in architecture and design refers to the use of computational design processes and their manifest effect on the architectural outcome, rendered or built. Due to the continuous progress in digital design tools and methods, the digital in architecture is a moving target that can only be pinned down temporarily. My approach here is therefore at once historical and also future oriented. The digital is, of course, part and parcel of the technological transformations that sweep through all aspects of our civilization, impacting and indeed upgrading our lives via digitalization of all products, services, and professional disciplines. The digital in architecture is thus inevitable, must be understood, embraced, and pushed forward. That this has to be explicitly emphasized in the year 2022, which is rather sad but also alarming. Where is the architectural equivalent of the thriving research plus business ecosystems of fintech, health tech, law tech in terms of integration of big data and architecture or artificial intelligence? Perhaps building information modeling comes closest, but concerns construction rather than design. Where is architect? The movement of parametricism comes closest to architectural technology, but the uptake of its insights, values, and methodologies remains marginal within our field. My focus will be here on the discipline's acquisition of new design capacities and distinction to the mere automation of prior ways of design. That is, mere digital drafting or mere visualization is not of interest here. A truly transformative ambition has been the hallmark of the avant-garde's investment into the digital form, its beginnings perhaps 25 years ago. The new digitally empowered design capacities and repertoires that have since been elaborated imply indeed a new characteristic architectural language and have manifested a new style with epochal ambitions, which is, of course, parametricism, right? Um, However, an ambitious concept of style involves more than a new architectural language. It implies a whole new paradigm for the design discipline with new purposes, values, related methodologies that are congenial both to the societal challenges posed and the technological opportunities offered by the new digital civilization, right? So we'll have a look at the societal and technological context of parametricism. The built environment must progress in step with the progress of society. It is therefore the task of the avant-garde segment of the academic discipline and profession of architecture to theorize and explore how best to guide the development of the built environment in ways that are congenial to the opportunities and challenges of societal development at the frontier of progress, largely induced by the convergence of computation and telecommunication we summarize here under the heading of the digital. What characterizes the related current socio-economic transformation and this is the shift from economy based on mechanical mass production to an economy of scope based on robotic fabrication and web-based services that can afford incomparably higher rates of innovations. This calls for and engenders a new level of urban concentration in knowledge-based creative industry hubs with a much higher degree of complexity and dynamism in the societal life processes, and thus also in the urban and architectural development. In this new era, all work becomes communication dependent, creative work, as the new technologies of production and services provision have a nearly infinite and instant capacity to utilize innovations, in stark contrast to the previous era of fixed assembly line production. This socioeconomic shift from Fordism to post-Fordism finds it congenial architectural response in the paradigm shift from modernism to parametricism as a prospective epochal style for the 21st century. Modernism was congenial to mechanical repetition, while parametricism delivers digital responsiveness. Postmodernism and deconstructivism were transitional styles from modernism to parametricism, and the interests in variety and complexity have been absorbed and enhanced within parametricism. The intensity, complexity, and dynamism of the social interaction and societal reproduction process can now be addressed via the new adaptive organizational and communicative capacities of a digital empowered process in which all elements of architecture have become parametrically malleable and responsive and subject to computationally empowered ordering processes. This digital upgrading is by no means automatic or trivial, but a hard-won capacity that requires the continuous investment of analytic as well as creative intelligence from the whole discipline, which means each and every one of you students need to be a part of this transformation. The as yet untapped potentials on the horizon make this investment a very well worth effort. So what you see over here in the image is precisely Fordism to post-Fordism, how in the past, in the early 60s and 70s, we would manufacture cars by hand, and we were, let's say, at a Ford factory, we were able to manufacture 10 cars and a man force of about 500 people working on just those 10 cars. And now we just need one or two people, and we'll be able to manufacture 500 cars in a single day using robots. Of course. So that is the technological shift that we are seeing in society today. There's faster ways to produce things, and simultaneously, this has to be reflected within architecture as well. Cars, of course, are one way to look at the build or anything that is put together in pieces. Le Corbusier in the past, in one of his books, Towards a New Architecture, compared cars and flying machines to architecture. But besides this, we also have to consider that in the past, we all had the same thing. Like we all live in the same apartment complex with 500 different apartments. They're all the same. We all eat the same kind of conflicts, and we drive the same kind of car to work and come back and enjoy the same kind of. In today's network society, we all need things custom to our needs, and that's why parametricism serves that kind of let's say need in order to have unique responses. We all eat different, we have different tastes, we have different um, approaches to life and philosophies, and parametricism serves precisely that. A brief history of the digital in architecture. Let's have a look at that. Although there has been earlier precursors, the use of digital design media took off and became impactful in architecture only in the early 1990s, albeit at first only within the avant-garde segment of the discipline, as in the experimental segment of the discipline. Columbia University introduced its paperless studio in 1994 and 1995, promoting a full-on switch to the digital. In 1993, when the seminal Architectural Digest Folding in Architecture was published, most work at Columbia University was still handcrafted. A year later, the whole top floor at the Columbia was equipped with brand new silicon graphic machines that were exceptionally powerful at the time. Running silicon graphics visualization software, simulation software, Alias and Wavefront, Maya, Autodesk Maya since 1998, that has been developed for the animation industry. Greg Lynn, the architect who now teaches at University of Vienna University, was the most prominent protagonist, theorist, and design teacher at Columbia. This was mirrored at the AA Architectural Association by Jeff Kipnis, graduate design group, which morphed into the Architectural Association Design Research Lab in the 1996 after Kipnis had left, which is what I'm a graduate of. The style of folding was given a boost and became the first architectural style in the digital era. The influence of the newly acquired NURB modelers was unmistakable. NURB surfaces and operations like lofting allowed for I'm, s- I'm sorry.
Sorry, sir, it was a radio disturbance. You can continue, sir. Sorry.
Yeah. Okay, so lofting allowed for coherent, smooth transitions between sectional spatial profiles. The congeniality of these new formal possibilities with the prior formal explorations of Zaha Hadid led to a rapid and enthusiastic uptake of the digital at Zaha Hadid architects, not least by the stream of digitally trained DRL students. So a lot of DRL students were starting to work with Zaha Hadid architects. The early days of folding were playfully explorative and oriented towards new spatial possibilities and morphologies. These were exuberant days of radical formal and conceptual innovation inspired by the exciting conceptual universe of philosophers like Deleuze and Guattari's A Thousand Plateaus, involving notions like the rhizome, multiplicities, assemblages, smooth space, line of flight. Are you trying? Is someone trying to say something?
I request all the participants to mute your mic. Sorry, sir, you may continue now, sir.
Yeah.
Thank you.
So, the radical and formal conceptual innovation inspired by the exciting, we already looked at how line of flight, deterritorialization becoming intense and abstract machine, the denigration of the whole movement as mere formalism was due to the ignorance and reductionism, while some protagonists were indeed just playing with forms. Play can also be very productive of new possibilities, especially in the context of design competitions where functional problem solving is inevitably posed. Play can enhance the creative power of new solutions, right? So, and through this, we also landed up at, tectonism, which is the latest stage of parametricism. We look at the first image over here, which is a part of foldism, how a surface can fold, like if you take a paper and fold it up, it becomes a part of foldism, of course. This is blobism, where we use blobs as clusters to connect them together, and swarmism, where we have multiple elements which work like swarms or swarms of flight. If you look at the sky, there are a lot of birds flying together, and that's how the swarmism came about, where there's one element right in the front, like there's one bird right in the front of the swarm of birds, which is leading the whole swarm into one direction. And of course, there's tectonism, integration of engineering logics, environmental, structural, and material, which is the bottom image here. So let's have a look at what tectonism really is. Tectonism is the only style congenial to recent advances in structural and environmental engineering capacities based on computational analytics and optimization techniques. All other styles are incapable of working with the efficiencies of the adaptive structural and tectonic differentiations that issue from the new engineering intelligence. They force its adherents to waste this opportunity and thus waste resources. Tectonism implies to the stylistic heightening of engineering and fabrication-based form finding and optimization processes. Tectonism is the currently most prevalent and promising subsidiary style, as in a sub-style within the overarching paradigm and epochal style of parametricism. In retrospect, we might find distinguished Tectonism and earlier phases of parametricism like foldism and blossism, which I already showed you here. This is foldism. It's in Azerbaijan, and this is in China. This is just a model. It's not been built yet, but this is, of course, used in several of Zahadid architects or even other practices as an example. In contrast to the earlier substyles of Tectonism, is embedded a series of technical rationalities that secure both greater efficiency as well as great morphological rigor, while maintaining sufficient degrees of design freedom to address programmatic and contextual contingencies. While the overarching general design agenda of parametricism pursuit of adaptive versatility and complexity, Tectonism pursues these with a much richer set of parametric drivers and constraints than earlier versions of parametricism. These drivers originate in sophisticated computationally empowered engineering logics that are now available to architects at early design stages via structural form finding tools like RhinoVault. RhinoVault is a digital tool for complex compression-only shell structures. And physics engines like Kangaroo, which is a plugin in Rhino Grasshopper, again, to approximate shell or tensile structures created by, this particular tool is created by a person named Daniel Piker. While analytic tools like principal stretch lines analysis and Karamba is again another plugin for Grasshopper. I would recommend every one of you students to start exploring these tools at a very early stage, like Grasshopper, Maya, or even advanced rendering tools, so you can get used to it in the future and what the world is really working with at the moment. This is not just an image that is created. This is actually being built in the Middle East right now, which is both all computationally, engineering wise, and sustainability wise. It is the most efficient building and one of the most efficient buildings of the world currently. So design research groups like ZHA Code, Zahadid Architects Computational Design Group, are developing custom tools to model the particular constraints of particular fabrication processes. We are making our own tools now, different building materials with their various related fabrication techniques. For instance, curved folding sheet material, tailored tensile fabrics, robotic hot wire cutting for molds, or 3D printing. Each impose a characteristic morphological constraints that can be built into the digital form finding engines, while each leaving plenty of freedom to the designer to find solutions to the complex organizational problems posed by their respective brief. So far, little computational empowerment has been delivered to this most fundamental of the architect's design task, namely the social organization by spatial and formal means that constitutes the societal function of the built environment. How can architecture's social functionality become computationally tractable when this key competency of architecture is the innovative ordering of social interaction process? So what I'm trying to convey here is that architecture is essentially the ordering of social processes. If you really understand why there are separate zones for doing different kinds of things, we understand that each zone is meant to serve a particular societal and social purpose. A bedroom, for example, in a house is meant to sleep. A lobby in let's say a university is where students interact, so that becomes an interaction process. Social interaction process. A cafeteria becomes a place for a person or a group of students to go and eat, perhaps. So it is the ordering of social processes. We're not just making spaces, but we are literally designing communication, how people interact, and this becomes extremely important. And when we can do that with an advanced and a better methodology to do these things, where you can also recognize things like the texture on the wall, the color of the furniture, the color of the lighting, or the curvature of the furniture. All these inform the user of the space a particular um, function. Let's say if the furniture is black and the lighting is white, and the texture on the wall are diagonals, you understand that this is a formal space, and you're supposed to behave in a formal way in that particular space. If the furniture turns white in another zone, you understand that it's an informal space. So we can literally design these aspects and control social interaction through these rules that we set. So this is what parametricism is all about. This is again some of the complex forms that are derived via using advanced architectural tools, which are parametricism based, like Maya, Grasshopper, that I already have talked about. Let's have a look at from intuition to simulation, social performance via life process modeling. When I just spoke about how social, we are literally designing social interaction. Well, I didn't simply mean that. We are starting to simulate these aspects of design as well. It is the authors, that parametricism has to shift its focus from technical to social functionality, from foregrounding formal principle design processes and engineering logics to the foregrounding of social ordering principles and societal processes. This shift poses new ambitious tasks while taking the versatile formal options, design process and technological advances of parametricism for granted as tools. Design research continues and must become explicitly oriented towards social functionality. This is a necessary aspect of growing up and becoming serious about making an impact in the world. In short, parametricism has to be relaunched as parametricism 2.0, where we also look at things like life process modeling. Due to its versatile and formal and spatio-organizational repertoire, parametricism is the only contemporary style that can adequately address the new societal tasks posed to architecture by the complex social and urban dynamics engendered by the information age. However, the way it's addressing these challenges on far still relies on the intuitive trial and error design browsing of experienced architects. The route to the computational empowerment of architects with respect to the crucial task of social performance can only be found via the development of new simulation capacity namely via agent-based life process modeling, where you can really understand how these agents or human beings will occupy the space, use the space, interact within the space, communicate within the space, work, live, um, co-work, co-live, um, everything from rest. Your entire life is uh, is simulated in a certain sense using this simulation methodology. This particular research agenda is called agent-based parametric semiology, which was also a part of my master's thesis. It's conceived as generalization and corresponding upgrade of the kind of crowd simulations currently offered by traffic and engineering consultants concerned with evacuation, circulation, and congestion. The simulations that must be developed to get a handle on the facilitation of various desired social interaction scenarios will have to be quite a bit more elaborate than the current crowd models testing circulation processes. And this is another aspect of parametricism that we are exploring. This is personally my thesis project at the AADRL. That was a very successful project, a live, work, entertain space in the Hudson Yards area of New York City. This is an image that I have personally developed along with my teammates at the DRL at the Architectural Association. So this particular project and several more that we will look at now are research-based projects. Agent-based parametric semiology, live process simulations are what we did through this research agenda. All these differentiating features imply changes and necessary complications, or positively phrased necessary sophistications for this much more ambitious modeling and simulation effort. The research team that was building up is now becoming larger, differentiated and sophisticated agent populations using a game engine named Unity. It's a game development software as base system, augmented with a lot of additional original coding. The development work concerning agent-based populations benefits from technology transfer from the game development industry. So we are integrating not just in the modeling of architecture, we are integrating tools from the animation industry like Autodesk Maya, and in the simulation we are integrating tools from the game development industry. In fact, I don't know how many of you students have played the game PUBG. PUBG is a very popular game. I'm pretty sure a lot of the students have been playing. Everybody around the world plays PUBG. Zahadid Architects have now developed a digital space within the game, which is completely, the building is designed by Zahadid Architects, and it's a parametric building, which can be accessed by the players through the game. So these are different kinds of spaces that design and agent-based methods have been followed in these through the textures on the floor, or through lighting conditions, the way that the furniture is set up, or through the curvature of the ceiling, or even the way that furniture comes together. The furniture can be brought together and taken apart. And so adaptive, responsive, creative, how artificial intelligence can upgrade architecture. The unprecedented level of dynamism in social interaction processes and contemporary creative industry work environments calls for adaptive, responsive, and indeed creative built environments. We need to push the boundaries of design. The discourse of so-called intelligent buildings has to be radicalized and related to the core competency of architectural design, namely the ordering of social interactions. If these patterns of interaction become increasingly variable, this implies the demand for an unprecedented level of real-time spatial flexibility. This demand can be better met by responsive, or better still, creative environments. Elements that semiologically inform and order the social processes must themselves become active intelligence agents. These artificial agents can technically be modeled in the same way we model the various human agents in our population. The next step here are thus truly intelligent, creative learning environments that operate in a self-directed fashion rather than merely responding in routine ways or waiting for instructions. The architectural elements that are meant to facilitate increasingly complex and dynamic pattern of interaction must become congenial participants in collective life process. Just as we like our human colleagues and partners to be spontaneous, creative, and self-directed in accordance with shared success criteria, we want to make our architectural robots to be self-directed, companions and collaborator. This is the dream for parametricism and the research based on parametricism. These are, of course, a few images that I wanted to show you that operate on multiple scales. It doesn't just operate on the scale of building, but it operates on the scale of lighting structures, furniture, and it can move from product to the whole city itself. How this structure, if you look at this one over here, it's a completely 3D printed chair designed in collaboration with Nagami. This is a glass. They're glass tools, but there's also a table along with this in the same design. And these are lamps which are parametrically laser cut. And this is CNC cut furniture. Each one of these are separately CNC cut and fabricated together. This is polycarbonate, and this is wood, which is carved by hand. So these are the various things that we can do today with the advent of digital fabrication and parametricism. This is a particular model that we are going to explore with the students at MIDAS for the upcoming workshop that we will have in the future. I will discuss this with the principal and the director, and we will see how we can get the students to model these kinds of complex structures or using advanced architectural tools like Autodesk Maya, and then render them in KeyShot. If there is a possibility, we might be able to fabricate these as well. Let's really discuss that and see how many students will be interested. And similar to the previous one, this is a different image of the same, but with more components. This might look like a play, but it can operate anywhere from, this can be a tiny little product, or we can change this to a whole master plan. Like I said, within the same object can transform itself on a different scale if we just enlarge it or compress it using digital tools. And we will have a look at that in depth in our workshop that we conduct in collaboration with MIDAS. These are, again, different kinds of complex 3D models that can be produced using these advanced architectural tools in matter of, let's say, we don't need to sit and model each and every component of this particular model for many, many hours, but we can reduce that time to a matter of, let's say, we can produce this in a matter of 1 hour if we really pay attention to what we are doing. So that being said, we will also have a look at how we can model an infrastructure project. We will look at how to model this particular airport by MADE architects in Beijing, China. This particular form of airports is becoming increasingly popular because it allows for more crowd handling and more number of airplanes coming in and flying out. We will look at how we can model this in detail on Autodesk Maya, and of course render it in KeyShot. KeyShot is another very advanced rendering tool that produces amazing renders in a very short span of time. Everybody, all of the students here in the room can follow my Instagram. It's Arc Intelligence, where you will be able to see a few models that are produced on Maya and a KeyShot, and we can try and see how we might be able to cover these topics and in the upcoming workshop. If anybody has any questions now, we can perhaps take a few questions for the next 10 to 15 minutes.
Yeah, thank you, sir. Thank you for the informative presentation on parametric design. I think we are very sure that our students will get inspired and will definitely implement on the designs and all. And we are looking forward for the workshop also. So now we move on to the question and answer session. I request the participant to use raise your hand option, which is available on your screen, or you can use the chat box also to post your questions. Is there any questions from the participant side, the students? I request the student feel free to ask your questions or any doubt regarding this webinar. Or else you can use the chat box also to post your questions. Yes. I think one person raised it. Miss Yokeshwari, you can unmute yourself and then ask your questions. Yokeshwari?
Yes,
Yeah.
yes, ma'am. Sir, you mentioned about the simulation of parametrism in social interaction and day-to-day activities of people. My question is, what is your opinion on the future of digitalization or parametrism on an economical and business aspect for the developing and underdeveloped countries? How could they
All
take
right.
up? It will be a boom for the society or a curse for an individual?
Okay. So as you already know, in any design or any aspect of engineered or product world, if there is something which is being produced at a very small scale, it costs a lot of money to be able to do that. But as and when something gets extremely popular, or there's a large number of consumers of the same product, we are able to bring the cost of the same thing comparatively, um, we can reduce the cost of the same product at a very large scale. Let's say if a product is being used by 500 people, we are selling it for, let's say, 1,000 rupees. If the same product is now being used by 5 lakh people, we can reduce the cost of the same product to less than, say, 30 rupees. So that's a 70% difference in when we increase the uh, number of users. And in the same way, the way that digital fabrication parametricism can be implemented in developing or underdeveloped countries is by integrating this at a larger scale. That's why it is extremely important to spread this to the masses rather than have only a certain small number of society that can use these kind of buildings. But if we spread it to a larger audience, and if everybody is agreeing with the particular style, because each one is theoretical, um, theoretically backed, we can of course reduce the price of the same, let's say, and the time. If we are able to produce something in 1 year with a smaller audience, we will be able to produce the same thing in 1 day with a larger audience. So that's how things have been improving in the West, and robotics as well. Something that costed, let's say, 25 lakhs in the past is reduced to 5 lakhs with the advancement of technology and the number of users. I'm giving you real numbers. There's a product, industrial robots, which used to cost 25 lakhs, are now only about 5 lakhs with the advancement of technology. In fact, if you look it up online. There's a company called Automata. This company is based out of London at the moment. They have considerably reduced the price of robots, desktop robots. They are students of the Architectural Association, which you guys can just literally look them up. I can perhaps share my screen once again to just show you this. This is the startup. They are. It's led by an Indian student, Suryansh Chandra, and Mustafa El Sayed. They made this particular robot, which would other companies are selling this for something like 25 lakhs, and they've reduced the price to just 5 lakh rupees. And they've received funding from other companies over over here. They first had a round of $10 million, and now they've raised another $50 million for their startup. So it's if something is done at a larger scale, we can of course bring the price down considerably. And
Okay, so thank you
that's my
for your
response. Yeah.
Yeah, thank you, Keshwari. So there is a question in the chat box from Mr. Sai Raghu. So he asked, what are the scopes of parametric architecture, especially in a country like India, with the higher population and the land availability in urban context for explorative structures getting lesser and lesser day by day?
Okay. Can I? So one of the things that is happening in a country like India is that parametricism is actually booming here. There are a lot of people who are adapting to the change. There are, especially cities like Mumbai, Bangalore, New Delhi, Hyderabad. These cities are increasingly adapting parametricism. If you look at the Mumbai airport, it is completely parametric. I'm talking about the old Mumbai airport. There's also a Navi Mumbai airport which is coming about, which is being done by Zaha Hadid architects. Large infrastructure projects, of course, can incorporate parametricism on a smaller scale as well, at an individual house scale as well. We can do it if, of course, there are a larger number of people who are willing to adapt this style of architecture. Which is being done slowly. The change will be seen slowly as a lot of architects from the ADRL or Columbia University are now coming back to their countries and setting up their own architecture practices in order to help develop their own nation. In terms of the land availability, there's of course there's a lifespan for a particular building. It's not that if one structure is built, we have to keep it for 100 years. That is no longer the case. We don't design buildings for more than 20 years now. So any building can be demolished and reconstructed. In fact, a building opposite to my house where I stay in Chennai was demolished and reconstructed within a span of 1 year. In just 1 year, they were able to demolish the old structure and rebuild it. And it's not a small project. It's a large project. And if we are able to do something like that in a very short span of time, I think more and more people will be willing to rethink the way that we look at architecture, and also implement complex geometry within the built environment. Because why stick to 90 degrees when we have 360 degrees, right? So that was the argument that Zaha Hadid posed in her thesis. So, and it's of course clearly understood that um, when you experience a space which is curvilinear rather than a rectangular, it is experienced a lot better. And you really need to experience a space in order to understand that. And that's why I also encourage all of the students in here to travel, to look at architecture, around the world. For example, the Dubai Expo, which is happening right now, is extremely a lot of extremely complex buildings. And well, I mean, you still young. I think there's a lot of time for everybody to explore these opportunities.
Thank you, sir. I hope sir would have cleared your doubts. And is there anyone want to ask any question? Mr. Sairago sent thanks a lot, sir.
All right,
Yeah.
you're welcome. Let's say we'll take one more question.
Yeah. Is there anyone who want to ask a question? You can use the chat box also to post your questions.
Anything about the workshops that we will be conducting at MIDAS?
Participant can also ask question regarding the workshop we'll be conducting in our next few weeks. So if you have anything, you can kindly ask here. So I think
So these are a few images that I just want to show to the participants that we might be able to explore and see how we can model from bio-inspired design to see natural processes, how mountain ranges would have been designed, or roots of a tree perhaps, or branches of a tree. These all form under, they all come under the branch of parametricism in a smaller scale, of course, but I'm just showing you the level of complexity that we can achieve. These are not just designed, they are actually simulated, perhaps, and we can see how we can use a simple surface to digitally change the shape of the surface in order to produce a complex model. These are very simple, beginner level images that I'm showing you that we can use to let's say upskill the students' knowledge on digital tools, um, and how we might be able to do the same using Autodesk Maya and Keyshot. Same goes for something like this, which is a stadium, or these are personal images of my project. Just gonna quickly glance through them for the students to have certain amount of knowledge. These are uh, furniture models and how we really develop them. This is how a floor plan would be developed. And that's it. Yep.
yeah, thank you, sir. Thank you so much
Great.
for your patience for answering all the questions.
You're
Now,
welcome.
now I request Professor Siddhartha to deliver the vote of thanks.
A very good evening to all. On behalf of Marg Institute of Design and Architecture Swarnabhumi, it gives me an immense pleasure to deliver the vote of thanks for this webinar to all dignitaries present here. I would like to thank our chief guest, architect Prabhat Arora, who honored this webinar with his inspirational thoughts. The possibilities of new solutions through parametric design tools is very much encouraging. I would like to thank our beloved principal, Professor Parisuttarajan, for being a constant source of motivation in our endeavor and efforts to excel in education. I would like to thank our head of the department, Professor Jayaraman, for his guiding force for every new step forward. I would like to thank Assistant Professor Hemalata and Assistant Professor Narayanan for organizing the event. I would like to thank our academic coordinator, Mr. Meenakshi Sundaram, our IT team, Mr. Franklin, for their technical support. Last but not the least, I would like to thank our faculty members, students, and participants for attending this webinar and making it a grand success. Thank you, sir.
Thank you.
Thank you, sir. Once again, thank you all for the participation. I request a participant kindly fill the feedback form. So we are looking forward for the workshop on parametric design. Thank you.
Thanks so much.
Thank you. Thank you. Bye. We'll meet.
Yeah, thank you, Prabhat.
Thank you,
Thank
sir.
you.
Thank
Yeah, after getting the feedback, we will try to call you and we will fix that workshop. Okay.
Thank you. I look forward to it.
Yeah. Thank you, Prabhat.
Good wishes for
Bye.
tomorrow's work. Okay, tomorrow's workshop.
Great. See you. Bye.
Bye. Bye.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you.
Thank you, madam. Bye.